Hey there guys, welcome to the first video for your 2.1 lesson, Is it a function? So first off, you see something that tells you that a relation is a relationship between input, which are our x values, and output, which are our y values. So a relationship is a relationship between our x and y values, or input and output values. Now a function is a special type of relation where for every input value, which remember this means x, there is exactly one output value, y. So for every x, there is exactly one and only one y value associated to it. And you may be asked to determine if different types of representation are functions, so the first representation we are going to be looking at is mapping. So if we look at mapping here, it is not a function if an output value points to two or more input values. So, if our mapping, where we have an output value, points to two or more inputs, it is not a function. So if I look at the first one, A is only pointing to one y value, which makes sense. For every x, there's one y. Same thing for B is only pointing to one y. C is also pointing to one y. D is also pointing to one y value or one output value. Now we have two input values that are pointing to the same output value. That is okay. You can have repeating y values. But as long as every input value only has one arrow, it's only pointing to one input value, yes, it can be considered a function. So every input has exactly one output. Now if we look at the second example, I look at my first input 2, and I see that it is pointing to 20, but it is also pointing to 40. So this one has an input value that has two output values. So right away, since it broke the definition of a function, it is automatically not considered a function. Why? Well, because the input value 2 has two. Remember, it only has to have two or more. It can only have one. The input value 2 has two outputs, the 20 and the 40, which makes it not a function. Each input should only have one arrow. Now 4 is fine, it only has one arrow. 3 is fine, it only has one arrow. But because we already broke the function, you only need to break the definition once for it to not be considered a function. So in this case, the second one is not a function. So that's mapping. Mappings are the ones where you kind of have these arrows. Now, other common types you will see for consideration of functions are tables and coordinate points. So in this case, we still have the same definition. Every x value has to have exactly one y value, except this time you can generally tell if it's not a function if there are repeating x values. So, whoops, wrong spot. There we go. So if we look at our first table, I see that there are no repeating x values. I have a -1, a 0, a 1. These are different. One's negative, one's positive. So they are considered different numbers. 2 and a 3. So since there are no repeating x values, yes, it is considered a function. Why? Well, there's no repeating x values. However, if I look at my second table, I have 3, 4, 5, 4, 10. You might have heard it, you might not have, but we have the repeating value 4. I see a repeating x value here. So in this case, it is not a function. You just have to break the definition once for it to automatically be considered not a function. So the input 4 has two outputs, and you can see that the first 4 goes to 7, and the second 4 goes to 14. So this is similar to the mapping, where we had the case of an input value going towards two different output values. Same thing here. We have our input value 4 going to 7, but same input value 4 also going to 14. That is not okay. For every x, there has to be exactly one y. Now we look at these set of points. You can notice there are quite a couple of different repeating values. I can see that I have, whoops, let me use the highlighter. Here, where I have 2 and 4, let me zoom in so it's easier to see. 2, 4, but also 2, 7. But not only that, you also can see that 2 also goes to 8. And then similarly, we have a -1 that goes to 5 and a -1 that goes to 3. So we have repeating values. However, we just had to find the first set where I saw repeating 2 here, and I could automatically know this is not a function because I have repeating x's. You can also draw something like this and say, hey, my 2 is going to a 4, my 2 is going to a 7, and my 2 is also going to an 8. Here's my input 2, output 4, same input 2, output 7, same input 2, output 8, which is not okay. Remember, every x has to have exactly one y. This one has 3 y's. Same thing you could have done for the -1. It's pointing to 3, and it's also pointing to 5. It only has to have exactly one y. This one has 2 y's. You can also have said that there are repeating x values. That would have been also good justification. Now graphs, we're going to be using something called vertical line test. So it is not a function if it does not pass the vertical line test, which I will abbreviate as VLT. Does not pass the vertical line test because it passes through 2 or more points, which once again, still a definition. Every x needs to have one y. So a vertical line, remember, it goes up and down. So let's imagine I draw this vertical line. Notice my x value, my input value, -1, so let me zoom in. Here's my -1, has only one y value, 3. It passes the vertical line test at this point. It only crosses it once. I can draw another line here. Still passes the vertical line test. I can draw another line here. Still passes the vertical line test, only touches it once. So on and so forth. Anywhere where I draw a vertical line that goes up and down, it only passes through the line once, so it is a function because it passes the vertical line test. We could also say every input value has exactly one output value, or for every x there is exactly one y. However, for the next one, if I do the vertical line test, my input -2 has output 2, but it also has output -2. Notice in this case for my vertical line test, there are 2 intersections. So remember, you just have to break the definition once for it not to be considered a function. So this is not a function. So it does not pass the vertical line test because my input -2, which you might not be able to see here if we zoom in quite a bit. This is where my input 2, remember input is also your x value, so for your x value -2 has 2 output values. Which are 2 and -2. So notice it has 2 right here and -2. Or you could just say it does not pass a vertical line test because it intersects twice. No matter where I draw my line, I will get 2 intersections. Now, however, if I had drawn my line here, I only end up with 1 intersection, but it just needs to break the definition once for the entire thing not to be considered a function. So because there is at least once where it passes twice, this is not a function. This one, however, no matter where I drew my line, I always had 1 intersection. So for every x, there was exactly 1 y. Over here, for the most part, for every x, there is 2 y's, which is not the definition. So this is not considered a function. So generally how we decide what is or not a function, so make sure you know the definition of a function and how to tell the difference between mapping, which are these examples, tables, and points, as well as graphs. You can now move on to your practice page.